When you're building a piece of software, you're not just slinging code together. No, you're an architect. You're laying a foundation. And just like building a skyscraper, the blueprint you choose right at the beginning, it determines everything. How fast you can build, how high you can scale, and yeah, whether one tiny little crack can bring the whole thing crashing down.
Yeah, so that's really the big question, right? What's your blueprint? Are you building a single, solid skyscraper that stands tall and proud? Or are you building a flexible, sprawling city of interconnected buildings? Each one has its place. And today, we're going to break down two of the most foundational blueprints out there, the classic monolith and the distributed service-oriented architecture, or SOA. So here's our game plan. First up, we're going to dig into the original blueprint, the monolith. Then we'll look at a totally different approach with SOA. After that, it's showdown time. We'll put them head to head. Then we'll get practical and help you figure out which one is right for you. And finally, we'll see how this is all part of a bigger journey of evolution. So let's start at the beginning. All right, first up, let's talk about the original gangster of software architecture, the monolith. Think of this as the all-in-one foundation. For a long, long time, this was just how you built software. So what is a monolithic architecture? Well, the name kind of gives it away. It's like one giant, indivisible stone. In the software world, this means your entire application is a single, unified thing. The user interface, all the business rules, how it talks to the database, it's all interconnected, all in one codebase, and deployed as one single package. And you can see just how clean this flow is, right? It's just a straight line. The user interface talks to the business logic, which talks to the data layer, and it all points to one single database. There are no complicated network calls or services to worry about. It's beautifully simple. So the big takeaway here, everything is just mashed together in one code base. When you want to deploy an update, even a tiny one-line fix, you have to redeploy the entire application. Its pieces are tightly coupled, meaning they're all tangled up together. And this has a huge impact on scaling. If, say, your user profile page gets super busy, you can't just give that one part more power. Nope, you have to scale the whole thing. And look, don't get me wrong, this simplicity has some huge advantages, especially when you're just starting out. It's way easier to develop and test because, well, everything's in one place. Debugging can be a walk in the park since you can trace a request from top to bottom in a single application. And performance, it can be screaming fast because all the communication is happening right inside the same process. No network lag to worry about. But, and this is a big but, as your app gets bigger, that beautiful simplicity, it starts to feel more like a prison. You can't just scale the one part that's busy. You have to pay to scale everything. A bug in some minor forgotten feature can absolutely bring the entire system crashing down. And want to try out that cool new programming language? Good luck. It's almost impossible when everything's so tightly woven together. This is what eventually forces developers to look for a better way. So all those problems we just talked about, they force developers to look for a totally different way of thinking. And that brings us to service-oriented architecture, or SOA. This isn't about one giant building. It's about building a city of independent, specialized services that all work together. Okay, so the definition of SOA is basically the exact opposite of a monolith. Instead of one unified app, SOA is a collection of loosely coupled services. Each service is its own little mini application that can be developed and deployed all on its own. They aren't directly wired together. Instead, they talk to each other over a network. And wow, the structure here looks totally different, doesn't it? A request comes in and hits this central communication hub, often called an enterprise service bus, or ESB. The best way to think of it is like a really smart post office. It gets a request and knows exactly where to route everything. This part goes to the user service, this part goes to the order service, and that part goes to the payment service. Each one is its own independent thing, and they often even have their own databases. It's a true distributed system. The whole game here is that each service has one very specific job, and it does that one job really well. But the key word is independence. The team working on the payment service can update and deploy their code whenever they want, without ever having to talk to the user service team. And because they all communicate using standard network languages, these services become like reusable Lego blocks that the entire company can build with. And this is where you really start to see the magic, because this approach solves a ton of the monolith's headaches. That payment service can be used by the website, the mobile app, even by internal accounting tools. If the product catalog gets slammed with traffic during a sale, you can just scale up that one service. You could write a recommendation engine in Python while your user service is in Java. And if one service goes down, it doesn't necessarily take the whole ship down with it. But, there's no free lunch in software. All this amazing flexibility comes with its own set of headaches. The whole system is just way more complex. Every time services talk to each other over the network, you add a little bit of delay. And that smart post office, the ESB, it can become a massive bottleneck, or worse, a single point of failure for everything. And trying to trace one user's request as it bounces between 3 or 4 services, it can feel like a serious detective work.
All right, so we've met our 2 contenders. 2 very different blueprints, 2 very different philosophies. Now it's time for the main event, the head-to-head showdown, where we can make the trade-offs crystal clear. Okay, this table breaks it down perfectly. Just look at the coupling row. A monolith is tightly coupled. It's a tangled web. SOA is loosely coupled, which gives you that freedom and independence. And that directly affects deployment. With a monolith, it's all or nothing. With SOA, you can push out updates to individual services. And that leads to the biggest difference of all, scalability. Monolith, you scale the whole thing. SOA, you can be surgical and scale just the one service that's getting hammered.
Okay, let's make this super practical. Imagine you're building an online store. In a monolith, when someone places an order, it's just a series of super fast function calls happening inside one process. But in the SOA world, the order service has to make separate network calls to the payment service, then to the inventory service, and then to the shipping service. It's definitely more resilient if one part fails, but it's also going to be slower because of all that network chatter.
All right, so after all that theory, we get to the million-dollar question. Which one of these is actually right for you and your project?
Look, a monolith is an absolutely fantastic choice if you're a startup building your minimum viable product, your MVP. If you've got a small team, fairly simple business logic, and you just need to move fast and get something out the door, the simplicity of a monolith is your best friend. Don't over-engineer things from day one. Now, on the flip side, SOA really shines in big, complex enterprise settings. Think about a giant bank. They might have one customer account service. That one service can be used by the ATM network, the consumer mobile app, and the internal website for bank tellers. When you need that level of reusability across tons of different teams and applications, the structured, organized approach of SOA is a massive win. But here's maybe the most important thing to remember. This isn't a one-and-done decision. It's not permanent. Your architecture is not set in stone. In fact, most successful systems end up following this natural path of evolution, starting simple and getting more complex only when the business really needs it.
It's funny. A lot of the huge tech companies you use every single day, they started out as a simple monolith. As they grew and hit those scaling walls we talked about, they began a long, careful process of breaking it apart. Maybe first they'd refactor it into a more organized modular monolith, and from there, they'd start pulling out the most important pieces into a full-blown service-oriented architecture. It's a super common journey.
So this chart is great because it helps you see where everything fits on a spectrum. On one end, you've got the giant monolith, one huge service, everything combined. Way on the other end, you've much smaller, super specialized services. And SOA, it sits right in the middle. It's that first big step away from the monolith towards a world of independent, business-focused services that can all work together.
So at the end of the day, this choice between a monolith and SOA, it's not really a tech choice, is it? It's a business strategy. It's a choice between speed and simplicity versus flexibility and scale. And that leaves us with the big question you have to ask for any project. Are you laying the foundation for a single, perfect skyscraper that's built to last? Or are you designing the blueprint for an adaptable, ever-changing city that can evolve with the times? The future of your software really does depend on that answer.